Hi, it's exam one time. So, in your infinite wisdom, you picked to have your exam on Friday, Saturday, Sunday, 23rd to 25th of October, which is not this weekend, but the next one. And the exam will be on, oops, so exam, there we go, is on Canvas. That is the most important thing because there will be no other exams posted anywhere. So exam is going to be on Canvas. It's going to be 90 minutes, about 10 questions, 11, 12, whatever. Usually these exams are longer than the in-class ones to prevent from looking up the answers. So you have to move at a little faster pace than the regular exams. The fact that you might want to try and look examples up, even though we've seen that examples are varied enough and most of the stuff doesn't solve it anyway. So and the fact that what I told, that if you don't know this course, your education in engineering is effectively over because you won't be able to pass any of the later courses. But anyway, so we're covering chapters 1, 2, and then 3, 1 through 3, 4. That is, what is that? About 14 sections if you combine the numerics into a single section. The 14 sections. So this is your midterm or exam one, whatever you want to call it. And there are a few things that you should know. But before we go there, I just need to make sure that you know that you have 5 minutes to email your work since the time you end the exam. So 5-minute time to send email with work. So 5 minutes since you end your exam. So your exam will either end because the 90 minutes ran out, and then exam locks, or you submitted the exam early because you were done earlier than 90 minutes, and the Canvas logs that time, exactly the hour and a minute and a day, everything. And then we have to compare that to the time when your email with your work came in. If it's longer than 5 minutes, then that effectively extends the time for you to change answers and so on, which is obviously considered cheating. Now, the other thing also is that you have to type in your answers, just answers in Canvas, and they have to match your work. Otherwise, work is not counted then. So type answers in Canvas. So no steps. Right, steps are on the paper, but the answer from the paper needs to match the answer on Canvas. Some students obviously were trying to cheat by, just answering whatever in Canvas, then took another day or two to solve the exam fully, and then send the email 2 days later with all the work, and then obviously nothing matched. So all of those cheating techniques are very well known to us. We also know what the form of certain websites answers is, and the form what we gave in class and so on. We also know the form of answers from other universities if you're looking for help from other students and so on. So we know how to spot, right? It's enough to find one problem you cheated on, so we know that the whole thing is invalid. But as I said, I don't have to worry about it. The thermodynamics is coming up for many of you and some other courses. So if you don't learn differential equations now, you will learn it then. So yeah. Now let's take a look at, so this is the basics, right? The exam is on Canvas, 90 minutes long, and then it locks. If you submit it earlier, then you're done earlier than that. You have 5 minutes to send either picture or a PDF. If you have a scanner, you can scan the work, and then email those to me, and the timestamp needs to be within 5 minutes of the time you ended the exam. Now, some students like to embed those questions in the work in Canvas. That's also fine. You can do that. Take the picture of your work and just attach it as a picture within the question itself. It does require some technological competency, so if you are able to do that, then that's even better. In that case, you don't have to email, you don't have to worry about the time limit or anything like that. It's just the answers are right there. And it's also easier for me. I mean, right? The work is right there. I just need to use the scroll. I don't have to open the email and download the picture and look at it. But it's not required. So it's either that or email, whatever. Just get it in. All right, so now let's take topics. So we have the chapter 1 stuff, which is definition of ODE, and then classification, linear, non-linear, first, second, third order, homogeneous, non-homogeneous, right? So that's the classification. Then we have slope fields. If you remember those small lines, right? Then we have separable equations. We have integrating factor. We have substitution. We have exact equations. And that's the stuff from chapter 1. Now I am going to put in the modeling, which is the word problems. And this is mainly the conversion of a sentence to an ODE, ordinary differential equation. So if you remember when I said the change in population is proportional to population. You can also have inversely proportional. You can have if you remember, the Newton's law of cooling was stated as the change in temperature is proportional to the difference of the temperature and the room temperature, right? So ability to change the words into an equation. Now, whether there's going to be solve the equation or not, that's irrelevant. The most important skill, the one that computers still can't do, is to observe a situation and write the differential equation for it. Then you can ask computer to solve differential equation, right, in the workforce, but no one is hiring you because you can solve differential equations. In that sphere, you're irrelevant. Computers do it much faster. Your job is to observe the phenomena and come up with a differential equation. So for your survival and work later on, here is what's important, and all of this is nonsense, right? But in education, right, all of this is equally important. So yeah, there it is. So modeling, making sure you can do that. Now we have the chapter 2 population, and we have that logistics model. So that's again word problems there. They are very simple because you just need to plug in the numbers in the correct spots. Those problems are probably the easiest thing you have in the entire the entire exam, because the equation, we already know the equation, right? It's the logistics equation that we had with the carrying capacity and constants and so on. So, that should be just very simple. Then we have the stability stuff. And
I'm typing in read and it's not working.
Okay, I'll come over. So we have the stability problems. That's the ones with limits we talked about, and solutions going in or out. There's a full lecture online. Then we have the acceleration velocity models. That also had some word problems in there. We had the parabolic motion and terminal velocity, all that good stuff. Again, the equations are all the same. I mean, we already derived all of the equations. It's the matter of, should I say, mindlessly plugging in numbers where they go to come up with an. And then you have the numerics. Numerics meaning Euler, improved Euler, right, and Runge-Kara. You are using the calculator in this case. Now, some of you will say, well, we wrote the code for this. Can we use it? Yeah, I can't stop you. Obviously, if you wrote the code, that means that you are somewhat competent to have a job in STEM. If you didn't write the code, then yeah, good luck. Because everything is computers today and programming. In either case, you are going to have one or two problems to run one of the three algorithms. So hopefully that is not going to make any problems, whether you're doing it by hand or you are plugging it into the software. Now, obviously, if you plug it in software just to check, I don't know about that, but you need to send in the work so I know that you used correct procedure to do this. So that's something we need to be clear. And finally, chapter 3. Chapter 3 is going to be introduction, so the second order equation. And this is where you have your three cases, R1, R2, or repeated, R, or complex R. And then you have your constant coefficients. And then you have mechanical vibrations. Mechanical vibrations are the ones where you have the word problem, again, from what we did last. So, the maximum of, I would say, 4 word problems, and the rest is calculation. So you have like 4 word problems. The word problem in mechanical vibrations immediately takes care of a complex variables and a constant coefficient, like just having that word problem. And then maybe additional problem for either repeated or this one. So there's the 2 problems from chapter 3, let's say. And then 1 problem for this or 2. Then 1 problem for acceleration, 1 problem for stability. The word population modeling can combine in here. So there are ways to combine these sections together. What you must have, what you absolutely must have, separable equation. You must have this one, and then one or the other, maybe both. Depends on how long the exam is. So I'll make the exam whatever I can solve in like 20-25 minutes. Should be good for you guys for 90 minutes and so on. So these are the things that are there on the exam. in terms of the topics. We stop at 3.4. The stuff we did today in class is not on the test, obviously, because we are making that cut right there. And then when we do exam 2, we are going to recycle entire chapter 3 and then add chapter 4 or whatever to it and move along. So that's it. The basic specs, there will be obviously announcement in Canvas. You will know the details of that. Announcement in Canvas will be there, and then we'll go down to, I'll give more details and make sure that you are emailing your answers. Any questions and concerns regarding the exam? Oh yeah, it has to be done in one sitting, right? So exam has to be done, I'll put it here, one shot, okay? So you can't start your exam on Friday, save it, and then continue on Saturday afternoon. Once you close the exam is done and done, right? So one shot for the exam, those 90 minutes. Okay, if there are no questions, then we're going to switch to the math portion. If you have any questions.